In this lesson, we'll go over the basic server architecture and Project Lombok, which we use in the server implementation. We'll start with some basic information about the server and then dive into a quick Lombok overview. So first, let's talk about the database. Unlike previous modules where I chose to use MySQL, this time around I picked H2 for the database since it requires literally no setup. I wouldn't use it for production, but since the whole complexity of MySQL is covered in other modules, this just isn't necessary. Lombok is used to make the server code tiny and devoid of boilerplate. This is pretty cool. We don't really need much in terms of web services. If we had authentication and authorization, there would have been more. I could also implement paging support and more complex requests for various segments of the UI, but those are pretty obvious if you've gone over the feed section of the Facebook clone. The authentication aspect is the big missing piece here, and I just didn't want to get into it. It's usually one of the more painful aspects of building a server, but since this is a mobile course, I didn't think it's very important to cover again, as it was covered in previous modules. Let's start with a POM file. This is all pretty minimal. First, we have the standard declarations. We use Spring Boot 2.2.2, which is the current version at this time. This code is generated with the Spring initializer, which I described before. This declares the H2 database instead of MySQL. And here we declare the use of Lombok, which I'll get into shortly. I also added a dependency on Apache Commons I/O, which is pretty useful for small utility calls. Lombok is a set of tools that include IDE plugins, libraries, and runtime tools. They essentially try to modernize the Java syntax using special annotations, and it does a pretty great job at removing a lot of the common boilerplate from Java 8 syntax. Their biggest claim to fame is removing the getter and setter boilerplate code from Java. In this module, we'll use Lombok in the server. It works for Codename1 app code, but we won't touch on that. The main reason that is that the value of Lombok diminishes thanks to properties, so we don't need it as much. But if you need it, you can see this tip about installing Lombok for a Codename1 app. Let's look at a few examples of using Lombok. Notice that these examples are picked directly from the Lombok developer guide. Here we have a class with 3 fields, but only one of them is marked as non-null. As such, we can't construct this object without the description field, as we would have an invalid object. So we have a private constructor that accepts this required field. To create the actual instance of this class, we use the of method, which accepts the required description argument. So you would be able to just write constructor_example.of description. That's pretty nice. But it took 5 lines of code, not including curly braces or spaces. That's a bit verbose. That can be achieved with one annotation in Lombok. You just define the constructor and the method name that you wish to add as a static factory method, and voila. It works exactly like the code we saw before. You can literally write constructor_example.of description. The other constructor is for subclasses. It accepts all of the state members and also makes sure to fail if we try to violate the not null annotation. Notice it's scoped as protected, so it would be used only when deriving the class. This can be implemented with a single line of code. The all_args constructor annotation does all of that implicitly. It also has an optional access level property which defaults to public. The inner class is pretty simple. There isn't too much to save here, but still there's a bit of verbosity. We can implement the blank constructor using the no_args constructor. Notice that this example is a bit synthetic. Normally we would use this annotation in conjunction with other constructor options to indicate that we also want that option. We already saw non-null, being used before, so this example should come as no surprise. This annotation can also apply to method arguments, etc. The method can now assume the variable isn't null. Notice that this usage is a bit stupid, as the person.getName call will throw a null pointer exception anyway. But if you invoke code that might propagate null, it could be useful. Let's move on to another cool feature of Lombok. Notice that this code can be improved by using the Java 8 try with resource syntax, so this isn't as beneficial, but it's still pretty cool. This block can be written like this, which is as terse as with the try with resources code, and possibly even more terse. Lombok's claim to fame has always been getter and setter elimination. So this whole block of code can be replaced with this. Notice that this is still relatively verbose, as we want a protected setter. So let's see something that's even more terse. First, notice that the setter for age as package protected access has package protected access, while the getter is public. Also check out all the boilerplate code we have for equals and toString. This can be optimized with some of the newer objects class methods, but not by much. The boilerplate doesn't end though. We have a hashcode method too, and a non-trivial inner class with a static creation method. Notice that this is the required args constructor syntax we mentioned before. That code that includes pages of data can be achieved using the @data annotation. It includes getters, setters, toString, and hashcode implicitly. Notice you can explicitly override the definition of a specific setter from data, as we did for the case of age. Another common task is variable definition. Again, there's a lot of boilerplate here, so much that Java defined a new val keyword, but this isn't yet available for Java 8, which is used by most of us. Lombok added two keywords, val and var. Var lets us define a variable that can change, a mutable variable. Val defines an immutable variable, effectively a final variable. There are a lot of annotations we didn't cover here. @value is the immutable variant of @data. All fields are made private and final by default, and setters are not generated. The class itself is also made final by default because immutability is not something that can be forced onto a subclass. Just like data, the toString, equals, and hashcode methods are also generated. Each field gets a getter method, and a constructor that covers every argument is also generated. The builder annotation produces complex builder APIs for your classes. @builder lets you automatically produce the code required to have your class be instantiatable with code such as person.builder.name shy.build. Notice that this works nicely with the @value annotation to produce immutable classes with the builder pattern. @sneakythrows can be used to sneakily throw checked exceptions without actually declaring this in your method's throws clause. Since checked exceptions are a feature of the Java language and not of the Java bytecode, this is technically possible. Synchronized is a safer variant of the synchronized method modifier. The synchronized keyword locks on this object, which is problematic as it exposes the lock state externally. This annotation implicitly creates a hidden $lock object and synchronizes on that object. The next best alternative to a setter for an immutable property is to construct a clone of the object, but with a new value for this one field. A method to generate this clone is precisely what @with generates. A with field name method which produces a clone except for the new value for the associated field. You put @log in your class, you then will have a static final log field, initialized as is the commonly prescribed way for the logging framework you use, which you can then use to write log statements. Notice that there are a lot of annotations you can use to describe explicit log system you want to use in the project. You can let Lombok generate a getter which will calculate a value once, the first time this getter is called and cache it from then on. This can be useful if calculating the value takes a lot of CPU or the value takes a lot of memory. To use this feature, create a private final variable, initialize it with the expression that's expensive to run, and annotate your field with @getter lazy equals true. The field will be hidden from the rest of your code, and the expression will be evaluated no more than once, when the getter is first called. There are no magic marker values, i.e. even if the result of your expensive calculation is null, the result is cached. And your expensive calculation need not be thread safe, as Lombok takes care of locking. Most of this is taken directly from the project lombok.org/features/all tutorial, but there's a lot more of information there. Thanks for watching. I hope you enjoy the rest of the course and find it educational.